This time in Math 30-1, we're looking at our last topic in Chapter 8 on logarithms. Topic 8.4, we're looking at logarithmic and exponential equations from page 404. When solving a log equation, we have to identify whether any of the roots are extraneous by substituting into the original equation and determining whether all of the logarithms are defined. The logarithm of 0 and a negative number is undefined. In example 1, we're asked to solve log base 6 of 2x minus 1 is equal to log base 6 of 11. Well, since the log base 6 is the same in both, we can say that 2x minus 1 has to equal 11. That means that 2x is equal to 12 and that 1x is equal to 6. What are the restrictions? Well, the 2x minus 1 has to be greater than 0, so that means 2x has to be greater than 1, and x has to be greater than 1/2. And we look, our answer is 6. It meets that restriction, so therefore the answer is sufficient. In B, we have log of 8x plus 4 is equal to 1 plus the log of x plus 1. What we're going to do is we're going to subtract the log of x plus 1 from both sides. That's got to equal 1. Now, the log of 8x plus 4 over x plus 1 is equal to 1. And if we apply the log rules, you can take away the log and say that's going to be 10 to the power of 0. Pardon me, 10 to the power of 1 is log 10, applying the log to both sides. And 8x plus 4 is 10 times x plus 1 if we cross multiply. 8x plus 4 is 10x plus 10. 4 is 2x plus 10. Take away 10 from both sides and you're going to get 2x is equal to negative 6 and x is equal to negative 3. If we plug that into either of the logs, you're going to find that you're going to get the log of negative 20 and you're going to get the log of negative 2. Both of those don't work. So the solution, negative 3, is called extraneous, and therefore we can say that there's no solution. In C, we have log base 2 of x plus 3 squared equals 4. Here we have log base 2 of x plus 3 squared is 4. That means that x plus 3 squared has to equal 2 to the power of 4. Now you can expand it and simplify it, and you get x squared plus 6x plus 9 is equal to 16, or x squared plus 6x plus minus 7 is equal to 0. And you can factor that now using the sum product method, and you're going to find that x plus 7 times x minus 1 is going to equal to 0. So those two numbers can't be used. So when x is equal to negative 7 or x is equal to 1, when you substitute negative 7 or x is equal to 1 into the original equation, log of x plus 3 squared is defined. And so when you look at it, the only value is when x cannot equal 3. In our next example, we're asked to solve and round our answer to 2 decimal places. Solve using logs. Well, if you take the log of both sides, we're going to have the log of 4 to the power of x is the log of 605. Now we can bring the x down in front. X log 4 is the log of 605. We can divide both sides by the log of 4, and you're going to get x is equal to approximately 4.62 using your calculator. You can check it by saying 4 to the power of 4.62 is equal to 604.7, which is very close to 605. In our next example, we have 8 times 3 to the power of 2x is 568. We want to simplify it as much as we can, so we're going to divide both sides by 8. Then you're going to get 3 to the power of 2x is equal to 71. Now you can apply the log rule to both sides, and you're going to get the log of 3 to the power of 2x is the log of 71, which is 2x to the power times log 3 is equal to log 71. Now you can divide both sides by the log of 3 to get 2x is equal to 3.88. Then you can divide both sides by 2, and you're going to get x is approximately 1.94. Again, you could substitute to check your answer. I'll leave that to you. Part C. We have 4 to the power of 2x minus 1 is 3 to the power of x plus 2. We're going to apply the log rule to both sides. Now we're going to bring the exponent down and put it in front. We have 2x minus 1 times log 4, and we have x plus 2 times the log of 3. If you expand that and simplify it, you're going to get 2x log 4 minus 1 log 4 equals x log 3 plus 2 log 3. Now we want to bring the x's over to one side so we can isolate them and solve for x. So I'm going to subtract x log 3 from both sides, and then I'm going to add log 4 to both sides. 2 log 3 plus log 4. Now what I can do is factor an x out of the first two, and I'm going to get x times 2 log 4 minus log 3 is 2 log 3 plus log 4. Now at this point, I can divide both sides by 2 log 4 minus log 3. Using my calculator to evaluate that, I'm going to get x equals approximately 2.14. The top will simplify into 1.556 and the bottom simplifies into 0.727. We're doing examples 3 and 4 from the book in class, but I'm only going to do example 3 here. You can read example 4 on your own. Paleontologists can estimate the size of a dinosaur from incomplete skeletal remains. For a carnivorous dinosaur, the relationship between the length s in meters of the skull and the body mass m in kilograms can be expressed using the log equation 3.6022 log s equals log m minus 3.4444. Determine the body mass to the nearest kilogram of an Albertosaurus with a skull length of 0.78 meters. Well, we're going to substitute s to be equal to 0.78 into our equation. 3.6022 times the log of 0.78 has to equal log m minus 3.444. Well, we want to solve for m, so we're going to add 3.44 to both sides. Now, we're going to simplify, and you're going to get 3.0557 is equal to the log base 10 of m. So that tells me that 10 to the power of 3.0577 has to equal m. And that's going to approximately be 1,137. So the mass of the Albertosaurus was approximately 1,137 kilograms. There's one more example, like I said in example 4, and then complete the questions for homework.